next we have our final panel for the mechanical engineering department. This is going to be about design for manufacturing, and I'm going to invite our panelists from Protospace, York, and Pantheon, and Pratt and Whitney to the stage. Thank you, guys.
Thanks so much for having us. My name is Kyle MacDonald. I'm an account manager with Protospace MFG. A little bit about my background. I have a Bachelor of Engineering Technology and Electronics Engineering with a focus on instrumentation and controls.
Hello everyone, my name is Jarret MacNeil. I'm currently the Engineering and Design Services Technical Manager at Protospace. So I started my journey into engineering in a small island in Nova Scotia called Cape Breton. I started at the Cape Breton University and transferred to Dalhousie University in Halifax, where I finished completing my degree in mechanical engineering.
So we have, I want to introduce who Protospace is first. So we are the world's fastest aerospace and defense supplier, focusing primarily on sheet metal and CNC machining manufacturing, and specializing in all of the requirements that the aerospace and defense technology sectors have. And we are a subsidiary of our parent company, Protospace Inc., who's been serving custom manufacturing for about 25 years now. We make sheet metal parts, machine parts, assemblies, a lot of stuff for avionics and test fixturing for the aerospace industry. I'm going to skip over the DFM slides so we can do a little bit of that in the discussion portion, but I'm going to talk about the two sectors of manufacturing quickly that we focus on. We have sheet metal manufacturing, which is typically cutting and forming, and Jarret will speak a little bit to that. And with CNC machining, we do subtractive manufacturing. So I'll pass it to Jarret to speak to sheet metal DFM, and then I'll take over machining.
So for sheet metal DFM, the big things that you really need to consider when designing is, first of all, the bend radius that you require for forming your bends, as well as your flange length and minimum cutout distance to your bend. These three all correlate with one another, as well as your fitment within an assembly. So first of all, the bend radius. You have to make sure that the bend radius you choose isn't going to interfere with any components that are inside of your case. Your flange length and your minimum cutout distance to your bend are going to depend on your bend radius, because these radiuses are going to require a certain size of die, and if your bend length or your cutouts fall within the width of that die, they may deform and cause your part to be out of tolerance, which is not something you want. And lastly, the fitment within an assembly. So every manufacturing process is going to have a certain type of tolerance. So you need to think about this when you are designing your parts. The best thing to do is go to the website or find a resource for the supplier you're looking to work with and determine what their tolerances are.
And from the CNC machining side of things, there's a lot of considerations to be had, but the biggest things are basically work holding. So how are you going to hold the piece of material that you're looking to remove material from, and what types of features are you looking to achieve? So if you have tight tolerance features, you have to be cognizant of the tools that we use to attain those features and what's physically possible. So cornering and edge radius, you have to be cognizant that there is a tool that's going to be used to remove the material, so you can't have a perfectly sharp corner in most instances. If you're manufacturing a part with thin walls, what considerations do you have to reduce tool chatter and potential breakthrough when dealing with specific materials? And every feature that you create has to be accessed by a tool that's going to be used to remove the material. So you don't want to make anything that's a blind feature that you can't reach with a tool, making it unmanufacturable. And we like to consider all these things as a whole, so you can consider making your parts as easy as possible. You don't want to spend a bunch of your time working with manufacturers, revising your design to make it manufacturable because you didn't consider what processes lead to that. So being cognizant of DFM throughout every stage of your design process is critical to the shortest path to success.
All right, good evening everybody. It's really great to be here. There are some familiar faces. I am a student here at York University. My name is Scipio. I'm the CEO and founder of Pantheon 3DP. I'm currently a master's student here at the Lassonde School of Engineering as well, and also an alumni of the Mechanical Engineering undergrad program. I think it's really cool. I've never had an opportunity at this level before, so really excited to talk about my expertise in additive manufacturing and my unique experience as a student and also a startup founder in this field. So, what do we really do at Pantheon 3DP? Some of you here in this room know of the emergence of Pantheon in the last couple of years, what we started as and where we're at currently. It's really been a ride, to say the least. In the current chapter of Pantheon 3DP, our main goal is to accelerate the adoption of 3D printing through the niche creation of 3D printed product brands. Now, what does that really mean when you break it down? What that means is we take the unique advantages of 3D printing and our expertise to apply them, and we create niche product brands like merchandise, miniatures, and other products to really unleash the potential of 3D printing. It's a really great technology. It's one that has been vastly underutilized, in my opinion, and we're trying to do what we can to really accelerate its adoption, and we think the best way to do that is through the creation of these product brands. So, a couple of our brands that we've created in the last couple of years is what we started out as, Pantheon Prototyping. And Pantheon was really just an on-demand 3D printing service focusing on technical applications of 3D printing. So this was actually what the startup was 2 years ago in my basement during COVID with a couple students. And we've really taken it from that small stage to where we are today, and I'm really excited to share that. We've been quite successful since then. And from there, in the last couple of months, we've actually expanded from the niche of prototyping to other brands such as Mercurio, in which we create custom awards and merchandise to really elevate your brand. We've also sponsored the trophies here tonight, so for the winners of those trophies, you get some really cool 3D printed awards. And we've also made Helios, which is a brand focused on creating high detail and high durability miniatures for tabletop games like Dungeons & Dragons and Warhammer, and that holds a sweet spot in my heart, being a tabletop nerd. So we're really excited to have serviced these brands, and we're also looking for very ambitious and entrepreneurial people that may be in this room that are looking to create the next brand under the Pantheon roof. And it may very well be your brand that we work with to actually bring to life. So if anybody is interested, we're just located at the other side of the room. Please come and talk to us. We'd be more than happy to chat and see how we can bring your brand to life through Pantheon 3DP. So today we're here to talk about DFM, and I wanted to share a little bit about what design for additive manufacturing is, so DFAM. Similar process to what the gentleman from Protospace spoke about. However, there's specific considerations you have to account for when you're working with 3D printing. First and foremost, you always want to have a deep understanding of the 3D printing process you're using and leverage the advantages of 3D printing to its full potential. So that's kind of where our slogan came from, of unleashing the potential of additive manufacturing. There's a lot of unique advantages in every manufacturing process, and especially with 3D printing, you want to understand those and really use them in your designs. So some of these could include the ability to lightweight, so you don't always have to manufacture parts at a fully solid density. You can reduce something called infill to make parts a lot lighter, which allows you to save manufacturing time, cost, and also just reduce the weight of parts as well. As well as the fact that you can incorporate complex geometries into your parts, which can allow you to incorporate multiple subcomponents into an assembly, reducing the complexity needed when, for example, you would initially make 3 parts out of a CNC machine. You can integrate all 3 into one part in 3D printing. So these are just some of the unique advantages, and it's really good to take advantage of those when you are designing for additive manufacturing. But at the same time, you want to account for limitations of the 3D printing process. That being said, 3D printing is a very interesting manufacturing process, but even somebody who runs a 3D printing company, I'm not trying to tell you to 3D print every single thing. It has its applications, and there are some shortcomings of it, and you definitely have to account for that when you're designing for 3D printing. And that kind of falls into the third point as well, to just be strategic with how you implement it. Know when to use it, when not to use it, and how to use it to its full potential. And if you incorporate this into every stage of your workflow, you'll be a very happy camper at the end of the day. If you don't, you'll end up with parts that may be more expensive to 3D print versus other processes, or may not be as well optimized when using this process. And I'm very happy to get into that more in the panel. So thank you.
So good evening, everyone. Glad to be here. I guess why they put me after these two, because I'm a consumer of the subtractive manufacturing process and additive manufacturing approach. So maybe it was strategically aligned, so hats off to you, Gordon. So for those of you who don't know what Pratt & Whitney Canada is, so Pratt & Whitney Canada is the largest portfolio holder of small gas turbines in the world, okay? So just to clarify, when if we talk about APUs, now remember my APU or Pratt & Whitney APU is different than the AMD APU, okay? So for us, APU is the auxiliary power unit that goes and sits in the airplane. So our smallest APU dates back a long, long time, goes on the Airbus 320. The newest APU is completely hybrid electric. It supports the hybrid electric functionality of the 787 airplane and so on. So on the turbofan side, our smallest engine is about 15-inch in diameter, so or 10-inch in diameter, about 1,000-pound thrust. And the biggest one is 50 inches fan, so generating 60,000-pound thrust. So it just covers a whole lot of range. Most of them are manufactured or are tested in one facility in Mississauga, some in Montreal, and then as volumes build up, eventually everything goes to Montreal as well. On the turboprop side, our smallest engine is about 450 horsepower. That goes on the Piper Meridian. Does anybody recall the Disney movie on airplanes? Anybody remembers the Dusty Crockhopper?
Yeah.
That's the PT-6A-42, okay? Anybody remembers the big Skipper World War airplane that came in and banged the competitor down and so on when they were flying through deserts of Arizona? Okay, so that's a Corsair with a Pratt & Whitney double wasp engine. That was the engine that won the war, okay? So you'll see these kind of emblems or sketch models elsewhere. Continuing on the turboprop side, our biggest one is a 5,000 horsepower engine that supports the Porter Airlines, the Bombardier Q400, which is now moved to Calgary to Viking Aerospace now. So basically, we talk about small engines and we are the widest portfolio holders, and that kind of makes us a dominant player in the industry. But we have been flying below the radar for a long time. It's only now that we are kind of coming up. A bit about me, I'm the Associate Director of Patents and Innovation Department. We fall under Enterprise Research and Technology. I've been with Pratt for 22 years. I spent about 18 years time on wing, came really as a technical specialist to working on different programs. I primarily worked on business jets, so typically Gulfstreams, Falcons. Any Taylor Swift fans here? All right, so she flies on a Falcon 7X, okay, so follow her. Any Oprah Winfrey fans? Any Madonna fans? They're all Gulfstream consumers, okay. Textrons are all Citation XLs and so on. You will see McCain Fries owning a couple of them. Irving Design, somebody from, Irving, they have a couple of Falcon 2000EX and so on. Okay, I'm an alumni of University of Toronto. Before that, I did my education in India. I have kind of around 20 patents on my name, primarily. Most of them are flying and so on. I do some hobby cycling. I'm also a volunteer coach. I teach little kids for FL robotics and so on. So that's all about me.
Good evening, everyone. So a lot of you may already know me if you are from mechanical engineering undergraduate, president, you already know me from the other. I'm Professor Leung. So I'm an associate professor at mechanical engineering and also at the undergraduate program director of the program. So in terms of my research, it is on multifunctional and smart materials development. So the text here is a little bit small, but let me talk a little bit about my research. So in my research, we are looking into developing new materials. Most of them are polymer-based. But what we are trying to do is, if we think about polymer or plastic, to keep it simple, they are like thermally insulated, electrically insulated. But we can try to add new functions to it. For example, we can actually make the polymer to be thermally conductive or electrically conductive, having to be doing some sensing, actuation, or energy harvesting. In order to do that, in this slide, what you can see is we're trying to look into 3 domains. One is we are looking into how we can use processing technology in order to modify or tailor the micro structure of material, such that we can tailor and tune the smart or multifunctional properties of the material. For example, today we have talked about, some of the panel speakers talked about, let's say, thermal management. So for nowadays when we talk about electronic device, a lot of like power will be used and it will be dissipated as heat when you do the thermal management. So in the past, we are thinking of like we need to use attach some heat sink, for example, in order to manage the heat. But how about if we can actually develop a material that's onion-based, but at the same time, like while it can like make it electrically insulated, but we can also make it thermally conductive. In that case, when we like let's say if we do injection molding in order to make the like enclosure packaging for the electronic component, can we integrate the structure of heat sink into the thermally conductive corner-based material? So in that case, it can actually help a lot in terms of the manufacturing. So that's one thing. And then nowadays we also look into, let's say, a lot of like these heat being dissipated and they will waste and dissipate to the surrounding. Can we actually reuse the heat and try to use it and harvest the energy from the heat and store it? For example, we can store it for some part with electronic device. So that's something that we're looking into. So I hope in the panel discussion I can provide you more insights related to manufacturing from the polymer perspectives.
Awesome, thank you guys. Please have a seat. We'll get into the comments shortly. Okay, we'll get into this. Now, I will also be the moderator for this panel. Bear with me, I'm an electrical engineering student, not a mechanical engineering student, but I'll do my best. Now, I do have some questions for you guys, and let's jump right into it. So, here's the first question. Why is design for manufacturing an important consideration for engineers? Anyone you guys can take it up, give it a shot. Again, this is also meant to be a discussion amongst yourselves, so feel free to ask each other questions too.
So I can start first. When we think about design for manufacturing, it is extremely important. Like nowadays, when we talk about product development, we want to reduce the design cycle time, such that the product can be go to the market earlier. So in that case, we are thinking about a concept called concurrent engineering, and that we want to introduce a perspective from the manufacturing team right in the early part of the design cycle, such that when we think about engineering design process, it's also always an iterative process. We don't want to wait until the very end and figure out that there is some manufacturing issue. In that case, if we need to go all the way back to the very initial step to change the design, the cost in terms of time and labor will be very high. So that's why it is very important for us to think about it from the very beginning.
I'll just build on to what my fellow speaker said, as somebody who really sells products for a living, the value proposition coming from selling parts is really, really important, okay? Now, what is really happening in the real world is we as OEMs do see supply chain contaminations, and OEMs could be anyone for that matter. I speak on behalf of Pratt, General Motors, Ford, and anybody's of the world, okay? So we do see fair amount of supply chain contamination, which in turn deteriorates the customer experience, leaving a bad name for us. So what we would really like to do is print products on demand when a customer needs it. So if a product is designed for its manufacturability, the manufacturing process can be shipped all over the world. So in theory, you could have a business jet that took off from Toronto, exhibited high temperature or consumed too much fuel, and is headed somewhere east. And then based on the data, we come to know that it's flying to Vietnam and it's going to have a 3-day stopover in Vietnam before really the execs fly back to Toronto. So with that data, we could, if the part is designed from a manufacturable perspective, we could have that additively printed at its nearest location, shipped to the repair facility before the plane really lands, have it replaced, and have the customer back on schedule. So design for manufacture is more important from a customer experience perspective.
To add on to that, speaking to Sunny's point about getting to market first or making sure that your projects are quick, making sure that you can design something that's manufacturable so you can find the flaws in it and iterate on it quickly is so critical to the design process and getting first to market. Mostly what we deal with from the customer perspective from the designs that we get submitted to manufacture is a lot of the DFM work, and we focus heavily on making sure that the most difficult part of that is figuring out how they interface with our tooling and our system. So making sure that we take that workload off of them and just have them focusing on the project, because the biggest thing on top of the speed to market is your focus on when you're working on a project. You only have a finite amount of things that you can focus on at one time. So if you spend most of your time revising your design to make it manufacturable, what other aspects of your project are going to be lacking because of that?
Yeah, I definitely think those are some really great points across the board. Specifically with 3D printing, there's a lot of nuance that a lot of people that haven't worked with 3D printing before are not familiar with. One of them being when you're working with any sort of FDM or SLA printing, overhangs are a really big feature that have to be accounted for. And what I mean by that is when you print something that is going to be printed in thin air, oftentimes support material is required to actually allow that feature to print successfully. And a lot of the time that isn't accounted for in the design before manufacturing. And what that leads to is a lot of customers having to pay extra for the support material that is then required to successfully print that part. If that was accounted for in the design stage, you could minimize those overhangs to a certain extent to reduce the cost of material, the cost to actually print a part, and also the overall quality of that part that no longer has scarring or any sort of tolerance issues because of where that support was placed. So these are all factors that you can account for during the design stage, and it shows why design for additive manufacturing and design for manufacturing as a whole is so critical.
Oh, thank you guys. I actually, to kind of touch on this, I do have two questions to follow up. So for Protospace and for Pantheon, you guys both have really fast design times and really low lead times. What things do you take into consideration? Like, what do you guys do to ensure that you can manufacture as quickly as possible to get that turnaround time?
My designers are also my 3D printing technicians are also my application engineers. And because they have that overlap, they have that very in-depth understanding of 3D printing, and when they're designing the parts themselves, they understand what the limitations and advantages of 3D printing are so they can capitalize on that, as well as communicate with the customer if there are any design issues or any flaws in whether or not those parts are manufacturable. And having that workflow and having that structure makes it a lot easier, knowing that myself and my team are experts in that field, and if problems do arise, we can stick to those lead times and work with our customers as needed.
Okay, sounds like there's a lot of thought that goes into the design review process. And I think I speak for all engineering where design reviews is, very important. So Professor Sunny, just to kind of put it back to you earlier, Nick talked about different materials. A lot of your research is with materials, thermal management. What are some considerations that go into material selection for design for manufacturing?
So when we think about manufacturing, of course, material selection is very important, like keys. And when we think of material selection, we think about what kind of functional requirements we need for the product, and then what are the constraints in terms of maybe the weight, the body, the footprint, and so on. And then, of course, when we think about the functional requirement, there may be multiple materials that can fulfill the functional requirement. But then, for a particular company, there may be some restriction in terms of the types of manufacturing facility that is available in-house. Then in that case, we will take the types of material that can really be done using the manufacturing facility within the company. So that's something that we need to think very carefully in the making sure segment.
Thank you. This is a general question to all the panelists. When you think about, there are a lot of students here, when they're doing their first design and they want to get it manufactured, or they want to come up with something to get, maybe a print, what are some pitfalls or what are some things they should really take into consideration as beginner designers or newbies?
I think this is a very well placed question because it exactly lets me build on to choosing the materials and I think while designing something afresh, it's more the duty cycle that needs to be considered. So I mean, if we look at, let's say, a turbo fan, for example, so you have, of course, that operates in a much colder environment, but it operates at very high tip speed. So your centrifugal forces are very high. It goes through twisting moments and so on. So there's a whole bunch of forces that need to be considered. On the other hand, when you go to the hot end of the engine, you suddenly have, I mean, you just talk about temperature, so then everything else kind of loses priority. I mean, I do invite everyone to go and pick up a combustor. It's right where you see my booth here. So that combustor weighs less than, it's probably 2 or 3 pounds. You can pick it up and have a look. But that generates enough thrust to pull 8 or 10 pathfinders together. Okay, so that's the kind of heavy duty or heavy duty cycle that the parts are visualized for and then need to function at every single time. So I think the biggest suggestion or my insight that I would share is new designers should more look at the duty cycle and then progress with their design.
So I can also add a little bit. Let's say for a student here, you may work on different project in your course as well. And when you work on the project, some of the time you may need to do your own machining of the parts, or maybe you do like 3D printing of the parts in order to build the system. One thing that you may need to consider, for example, in terms of additive manufacturing, if we are talking about using plastic, you think about, let's say, the dimension, the tolerance of the material. Because when you do 3D printing, like technically you have the melting process of the polymer, and then it will cool down, solidify, but there will be shrinkage of the material. So what you have designed have to accommodate these shrinkage. And if we have non-uniform cooling because of the non-uniform dimension for the parts, there may be some deformation of the shape. It may lead to some thermal stress that may create some crack and so on. So a lot of things need to be considered in terms of the shape and so on.
To add to those points, for young designers, the thing that we see the most that's troubling is when a design is over-constrained for no reason. So finding out what's critical to your design and your project and making sure that it's appropriately constrained to accommodate that within whatever manufacturing tolerances you're working within is critical. Because we've seen a lot of times where designers spend a large amount of time trying to figure out a tight tolerance design for an aspect of it that their project really doesn't require. So you waste time in the design process trying to achieve something that isn't required for your overall project goal.
Yeah, and also to add on to that, I think being a young designer myself, when I first started out using 3D printing, the most valuable thing for me was actually getting hands-on experience with that manufacturing process. It helped me to really in-depth understand how 3D printing works, its limitations, and what I could really do with it. And I think for all the engineers here, the engineering students, going to the sandbox, getting your own 3D printer, just finding a way to actually get your hands on 3D printing or any other manufacturing process allows you to much more fundamentally understand that process itself and then, of course, design for it. So I think that's incredibly valuable as well.
Another thing that I find a lot of people fail to think about when they're designing parts is the actual environment that these parts are going to be in. So a lot of times you might need waterproofing, dust proofing, or you might be in just a very high temperature area. So you have to think about, okay, if I'm in an environment that's very hot, what can I do to protect the internal components from that? Another thing with the dust proofing and waterproofing is what things will I need to consider? Will I need to look at gaskets? Do I need to have these parts welded? And if so, is the welding going to be so extreme that maybe I'm at risk of the parts warping and maybe I need to redesign because of that? So there are some things that need to be considered with the environment and the location of your parts and enclosure.
All right, thank you very much, guys. That's the last question from me. Actually, yes, so we'll be moving on to the Q&A from the audience. We'll take 2 questions for this Q&A. If you have a question for the panelists, please approach the microphone on my right.
My question's for Nick. So you mentioned that you can work with students to, like, what if someone has an idea for their own product brand, how might they work with your company to develop and launch it? Like, what's the process like for supporting those new ideas?
Yeah, so we kind of took this process from when we started with Pantheon prototyping, and it was kind of working with the customer on that initial concept, refining that concept with them one-on-one, building out a few prototypes, and then they would kind of go to another manufacturer to actually take that idea to market and mass produce it. What we kind of changed when we went and switched over to Pantheon 3DP is kind of being with them from that end-to-end process, still working with them to build out that concept, to create the prototypes, but for a specific niche or application, also working with them to create a small to medium production run of that product. And of course, it wouldn't work for every single product, but through that onboarding stage, we can kind of understand if the product idea you have or the brand you have in mind is a good fit, and we work with you to actually bring that to life through that process that we've created.
My question's also for Nick. So seeing a fellow York student start like a company, trying to change the game, it's really inspiring for me. So I was just curious, two things mostly. One, what made you want to start a 3D printing company? And what does 3D printing mean to you? Like, do you feel like it will rival or maybe surpass traditional manufacturing processes? Or do you think it's just, just a different way of doing things and you just want to specialize in it? Yeah, I'm dying to know.
But so I started Pantheon during COVID. It really was kind of just a thing of, the stars aligning in a way. Everybody, as you know, was at home. We lost access to the sandbox and other resources here on campus. And as an engineering student, those were really big resources that I relied heavily on. I was also doing mini design at the time, so we needed to create prototypes and parts for that course. And at the same time, with all of that going on, I had an uncle at the time who had his own company, and he was looking to start making custom housings for different router shelves and other products that he was installing at his customers' locations. So he ended up buying a really cheap, like $200 Ender 3, which is a very hobby-level printer, and basically approached me and said, I don't have the time to figure this out or put it together, but if you can do that and kind of make it a project for yourself, you're more than welcome to keep it. So I started with that 3D printer, making parts for him, I guess as my first customer, that I didn't really know at the time was my first customer because I didn't have a business set up. I made parts for myself for the mini design course, and then from there I was like, well, there might be some demands to kind of pursue that further with other students in engineering. And as I just started organically branching out to other students, I realized there's something I was deeply passionate about. I started to learn a lot about the manufacturing process, and I really fell in love with it. And so from there, I kind of built it up slowly, starting out as an on-demand service, but there are a lot of those out there that are a lot bigger than a guy in his basement with a 3D printer. So we needed to kind of find a way to carve our own piece out of 3D printing industry, and that's where we came up with the idea first to focus on prototyping as a niche, and then kind of building that out further to actually build our own 3D printed product brands. And your second question was, like, what does 3D printing mean to me? At this point, kind of everything, just because it's become my entire personality. It's a lot of, what I do. I come out to these events and I do it as a business. So yeah, it does mean a lot to me. And in terms of your last question, I don't think 3D printing will ever take over manufacturing as a whole. I think it's one of those technologies that is continuing to see evolution versus older ones, so that's really exciting to see. There's the recent advent of concrete 3D printers, metal is starting to get a lot better too. So it is cool to see these new applications and new uses, but I don't think it will ever get to a point where every single industry is single-handedly using 3D printing. I don't think it should either.
Thank you. Awesome, give it up for our panelists, everyone. Thank you guys so much.